All right, there's one last idea we want to talk about in section 4.2. Let's use the following example. Again, take notes with me. Let's have g of x equal 2x squared plus x minus 6 over x minus 1. And go ahead and factor. Hit pause and factor. You should have gotten the numerator to be 2x plus 3. No, that's wrong. You should have gotten the numerator to be 2x minus 3 times x plus 2 over the x minus 1. So from that information, you should know that there is a vertical asymptote at x equals 1. There are no holes because we didn't cancel anything out. There are two x-intercepts, one at 3/2, comma 0, and the other one at -2, comma 0. There's a y-intercept, which again is easier to get from the unfactored version. If you look at the unfactored version, put 0 in for x, you get -6 over -1. That's 6. So 0, comma 6 is the y-intercept. How about a horizontal asymptote? The degree in the numerator is bigger than the degree in the denominator. The numerator gets larger and larger a lot faster as x gets bigger than the denominator does. So there's no horizontal asymptote. You know, horizontal asymptotes are one kind of what some sources call an infinite asymptote. Infinite asymptote really means what happens as x approaches infinity. There's no horizontal asymptote, which means in this graph, as x approaches infinity, it's not going to level out like a horizontal line. But something interesting will happen. And to see what it is, I would like you to actually simplify the original function a different way. Simplify it by either using long division or synthetic division. You could use synthetic here since we're just dividing by x minus 1. If it was something more strange, you would need to use long division. So I'll practice the long division with you. In fact, why don't you set this division up, press pause, and come back when you've done it. You should have had x goes into 2x squared 2x times. When you multiply, you get 2x squared minus 2x. When you subtract x minus 2x, x minus -2x was 3x. You brought down the -6. You divided again and got plus 3. 3x minus 3. And the remainder was -3. So that means another way to write g of x would have been 2x plus 3 plus the remainder of -3 over x minus 1. Yeah, that's equivalent to the original g of x because all we did was we divided. Now let's look at this new version of g of x. What happens to that fraction part as x gets huge? If x gets huge, this fraction becomes insignificant. It becomes 0. And all that's left is this 2x plus 3. This 2x plus 3 becomes our infinite asymptote. It's not a horizontal asymptote. It's a slant asymptote or an oblique asymptote. You will get a slant or oblique asymptote anytime that the degree of the numerator is 1 more than the degree of the denominator. Once you understand this fact, think about what would happen if the degree on top was 2 more than the degree on the bottom, or 3 more. What would happen in the long division? What would the quotient look like? Because the quotient is this infinite asymptote. So again, infinite asymptotes could be horizontal asymptotes, could be slant or oblique asymptotes, could be other things too. But we don't have to talk about those other things today. So let's go ahead and graph this thing as best we can. I'm going to put my asymptotes in first. And of course, one of them was a vertical asymptote at x equals 1. And one of them is this diagonal line, y equals 2x plus 3. Well, you know how to graph y equals 2x plus 3. Looks kind of like that. Don't forget your intercepts. We have an x-intercept at -2 and another x-intercept at 3/2. And your y-intercept is at 0,6. From the points that are there, you can probably figure out that the graph's going to end up looking like this. But we can hold off on that and go ahead and look at that number line if you like the number line better. The places where the interesting things happen are at -2, because that was an x-intercept, 1, because that was a vertical asymptote, and 3/2. Each one of those factors only appeared once, so we are going to get alternating positives and negatives. Remember, it's only when you have an even exponent on one of those factors you get even multiplicity and you get 2 pluses or 2 minuses in a row. So from -infinity to -2, the graph has to be negative, and it has to hug this infinite asymptote, which is this diagonal line. And then you got to go positive up to the vertical asymptote. And when you get past 1, from 1 to 3/2, it's negative, and it's hugging this vertical asymptote. And then it's positive the rest of the way, and it hugs the slant asymptote. And there you have it. So, we've talked about holes. We've talked about these slant asymptotes. I want you to work in groups on both the problems that were due today, if you still have issues with them, and the next set of homework. And do the best you can, and when I see you on Tuesday of next week, we'll see where we're at and hopefully work it on out. Thanks so much. I hope the video wasn't too weird. I know me standing in an empty room with these headphones on talking to a board is kind of strange, but I like it. Bye.